Welcome to today's workshop, a teacher education curriculum to support computational thinking in compulsory schooling. The slide set and materials for today's presentation are prepared by Yasemin Gulbahar of Ankara University in Turkey. The supporting materials have been prepared by Arnold Piers from the KTH Royal Institute of Technology in Sweden, Valentina Dagieni of Vilnius University in Lithuania, and Erik Barensen of Radboud University in the Netherlands. Today's presentation concerns the work being done by a consortium in teacher education for computational thinking. This is an Erasmus-funded project to expand access to teaching resources for computational thinking education, and in particular for teacher training across Europe. The consortium itself is coordinated by Professor Valentina Dagieni of Vilnius University in Lithuania, and the partners you can see here on the slide spanning 10 countries across Europe. This has been a very dynamic group. We've been working intensively despite the pandemic, both online and in terms of preparing resources to bring to you the materials that form the main focus of today's workshop. And the consortium itself is spread out across Europe, representing a large fraction of the different teacher education systems and different school systems that are currently integrating computational thinking into their curricula in different ways. In particular, it's important to notice that some countries, such as Germany, have decided or have historically also had both programming and some computationally related informatics subjects as a part of their general school curriculum, as have Lithuania and Estonia, to name a couple of others. Whilst Sweden and Finland, in the introduction of computational thinking and programming into the school curriculum, have taken a rather different approach, focusing on integrating those areas of knowledge into other subjects that already existed in the school curriculum, in particular, for instance, technology or physics. So this presents enormous challenges in terms of developing resources for teachers across Europe. The consortium very early on was very clear with the idea that what we do here is not develop model curricula, because the teaching systems across the participating consortium partners were so different that this would be impractical. And it indeed seems impractical at a European level to propose an ideal curriculum that would later be adopted across all European countries in this regard. Such a large-scale political endeavour would require much greater coordination than a single project such as ours can achieve. Instead, what we're focused on is developing and making available teaching materials that can be both integrated into the curriculum of the different countries participating, but also are more widely useful. And we hope that in your participation in today's workshop, you'll gain an understanding of how those resources can be deployed, how they can be configured in your particular school or teacher training environment, and how you might be able to use them to deliver a more flexible approach to computational thinking education, both in teacher education and in school practice. So what is today's workshop really about? For the first part, you're going to hear quite a lot from me, Arnold Piers, Professor of Engineering Education from the Royal Institute of Technology in Stockholm. I'll be today's main presenter, but in the discussions after this presentation, you'll encounter a large number of other people in the project team as they introduce and scaffold some of the resources that we're planning to discuss in today's workshop. The workshop itself is designed to provide teacher educators and also teachers with resources and perspectives that focus on the STEAM disciplines: science, technology, engineering, mathematics, and arts, and also working on a variety of perspectives on computational thinking education, from primary school to very specific approaches, such as the one that I've been working on in challenge-driven education and constructionism. So in this workshop, what we hope to do is to introduce you, the participant, to selected parts of the modules that we've been developing, and also have the opportunity to provide some additional perspectives that help to enrich our approach and the pool of resources that we're able to offer you. You'll also gain some experience with a set of these educational modules, units, materials, and activities, which help to scaffold a flexible curriculum design approach. And again, the focus is not on curriculum design per se, but rather on providing resources that you can integrate into your own curriculum. How will this be conceived in the context of today's workshop? We're going to cover 6 topics that will last approximately 45 minutes. We will be presenting a conceptual framework for computational thinking, an overview of computational thinking concepts and practices, pedagogical approaches for CT integration, computational thinking for an integrated STEAM approach, integration activities that are appropriate for integration into K-12 education, so that is preschool to year 12 of compulsory schooling, and some reflections and some resources relating to the evaluation of computational thinking skills, both in the classroom and in the context of teacher education. So what is our conceptual framework for computational thinking? In particular, what we've been looking at is integrating computational thinking into an overall STEAM education framework, where we introduce cognitivism first, the TPAC framework, and then link that to a digital competency framework, inquiry-based learning, and project-based learning. And we're going to look more at those things throughout today's presentation. The concepts and practices that we're working on, we're going to introduce computational thinking as a concept and also as a problem-solving process. In stage 2 of the workshop, we'll be looking at computational thinking in terms of tools for addressing various disciplines through the lens of computational thinking. We'll then move on to looking at programming logic and algorithmic thinking and the teaching and assessment of computational thinking. And all of this is designed to scaffold your understanding, both in terms of teacher education and also how these types of resources can be used effectively in the classroom. Pedagogical approaches for computational thinking integration are many. In particular, we will bring up some examples here in the workshop of pen and paper activities, certainly educational games, some creative drama activity examples, music and dance activities, then also complexity exploration in the form of origami, tanagrams, papercraft, and programming toys, which all help to concretize aspects of computational thinking for pupils. In terms of computational thinking for an integrated STEAM education, here the module aims to contextualize the subject and to facilitate for teachers to embed computational thinking skills into subjects as diverse as languages, arts, and the humanities. In particular, this is an area that's relevant to Finnish and to Swedish education, where language, arts, and humanities teachers are expected to integrate aspects of programming and computational thinking into their curricula. And it's not, for many teachers, very clear how to do this. So it's important as part of the work that we're doing to try to scaffold this type of both teacher education and classroom practice and provide resources that help to simplify the process of this introduction of computational thinking skills into these subjects as integrated parts of what can be taught in the humanities. In terms of integration activities for K-12, here we will look in detail at online teaching and learning support, in particular, a system that has been developed at the University of Turku in Finland, where they're able to show that they can, through one weekly lesson and a homework of 45 to 90 minutes, substantially scaffold computational thinking development. Their exercises are well aligned with the curriculum in many countries, provide very simple personalization and differentiation for learners at different levels, and integrate very well into existing teacher workflows. Examples are shown on the screen behind me of different types of challenges that can be linked to curriculum components and then assessed. This system in particular has been very widely researched, recently receiving several international awards, and has been scientifically proven to have high impact on student learning development, both in computational thinking and in terms of mathematics education. And so we're looking forward to integrating that into today's workshop activities. Finally, the evaluation of computational thinking skills is non-trivial. Many of the modules that we'll be presenting in the workshop today include approaches to both specifying and evaluating computational thinking skills in both practical and theoretical contexts. It's very important here also to gain an understanding of what system support, in particular the system support that you see behind me on the current slide, can provide in terms of monitoring individual progress of individual pupils in the classroom. This type of strong support for teacher engagement and teacher follow-up is an advantage that big data and learning analytics can certainly deliver in the context of these types of projects. So in summary, today's workshop gives participants hands-on experience with the topics that we have selected and with selected learning activities which are extracted from our teacher education for computational thinking curriculum module development process. The intellectual outputs that have been developed in 3 phases. We've just completed a development and design phase, followed by a review and piloting phase. What remains ahead of us is optimization and production. This workshop will present you some of the intermediate products from phase 2, and certainly will help us to draw on previous results, but also hopefully to gain your insight and input as we present these types of resources. In particular, we're interested in how you could see them as being part of an integration of these types of subject matter into your curriculum. So I look forward to talking to you throughout the rest of the workshop, and thank you for your interest in this presentation. Thank you very much.